let's make use of the properties of vectors to prove that the diagonals of a rhombus intersect at right angles. Particular property of vectors, the scalar product, is useful in this regard. The scalar product of two vectors A and B is A dot B equals the magnitude of A times the magnitude of B times the cosine of the angle between them. And a rhombus is a parallelogram with all sides having equal length. So we have our rhombus and we've drawn in the diagonals. The diagonal AD, it will be equal to the sum of these two vectors. AD being a vector, AB is a vector, and BD is a vector that's parallel with the vector A and has equal magnitude, so it will in fact be vector A as well. So we can add B to A, and that will be equal to the vector AD. So AD, the diagonal AD, will be equal to the vector B plus the vector A. The second diagonal, BC, the vector BC, this diagonal will in fact be the sum of this vector, which is AC, and vector A, and BA. BA plus AC equals BC. But BA is the negative of the vector B, because it's in the opposite direction. So we can write BC as equal to the vector A take away the vector B. Now with the vectors AD and BC, let's take the scalar product of these two diagonals, and the angle between them is theta. And what we're going to try to show using the scalar product is that the angle theta is 90 because the scalar product is 0. Let's see if that works. The vector AD is B plus A. The vector BC is A take away B. AD dot BC will be equal to the vector B plus A scalar product with A take away B. And that will be equal to B vector dot A take away B vector with B and add A dot A take away A dot B. Now because B dot A take away A dot B will be 0, we have AD dot BC equals A dot A take away B dot B. Now this is the vector A scalar product with itself. That will be equal to the magnitude of A squared, because cosine 0 is 1. And with B dot B, it will be the magnitude of the vector B squared. Now with a rhombus, we know that all sides have equal length. So that must mean that the size of A will be equal to the size or length of B. And if that's the case, the magnitude of A squared take away the magnitude of B squared will be equal to 0. So we have found that the scalar product between AD and BC equals 0. So therefore we can deduce that cosine of theta equals 0, and therefore the angle between the vectors BC and AD is equal to 90 degrees. Therefore, the diagonals of a rhombus are perpendicular. i.e. at right angles to each other. So vectors are very useful for providing proofs of certain geometric theorems.